This section is about rational functions, section 4.4 in your book. The objectives for this section are finding the domain of a rational function, finding the intercepts, the vertical and horizontal asymptotes. Also, we'll talk about wholes. We'll describe the end behavior of rational functions and also sketch complete graphs. In this video, we're not going to cover all of these topics. I will have different videos. A rational function is, as such, you have a fraction, and the numerator is a polynomial, and so is the denominator. In this case, here's an example of a rational function. This is the parent function that you already know and recognize as the rational function. I have a polynomial in the numerator and a polynomial in the denominator, and we can have all sorts of rational functions. This, for example, is a little bit more complicated rational function. You can have second order terms, third order terms, both in the numerator and the denominator. When we talk about finding the domain of a rational function, what I want you to find is what x values are not allowed to be in the domain. That means what x values I cannot use for this function that don't work. And those numbers are the numbers that will make the function undefined. And undefined means a division by 0. So any x value that produces a division by 0, we will restrict the domain and say I cannot use that x value. So for example, in this case here, I have a rational function 1 over x squared. I can plug in any x I want to here, except x equal to 0, because when x is 0, this will make my denominator 0, and I will end up with, let me grab my pen. I will end up with, if x is 0, I will end up with 1 over 0. And that is undefined. That means I don't know what that equals. So I can't plot it on my graph. Therefore, the domain, you would write the domain for this function is all real numbers except x equal to 0. Any x is allowed except x equal to 0. That's how I would write the domain for this function. For this function, it's a little bit harder to see what x values I can use and cannot use. I'm trying to have my denominator to be any number except 0. So how do I know which x's will make this denominator 0? So what I do is I will make the denominator equal 0. I will solve, and that way I will find the x's that make the denominator 0, and then I'll exclude those x's from the domain. So this is what I do. I take my denominator, x squared minus x minus 6, and I will make it equal 0 because I want to know what makes this 0, what x value. Now, the first thing I do, this is a quadratic function. I have many ways of solving a quadratic function. I can factor, I could use the quadratic formula, I can complete the square, etc. I usually try to factor first, and if I can't factor, then I'll do the quadratic formula. But I'm looking at this polynomial, and I think I can factor this. And I can say this is x minus 3 and x plus 2 equal to 0. And now I use the zero product property that says if this amount times this amount equals 0, then one of these two has to be 0 or both. So x minus 3 equals 0, and I solve for x equals 3. And over here I'll have x plus 2 equals 0, x equals negative 2. This x equal 3 and this x equal negative 2, those are the two x's that if I plug into the denominator will make my denominator 0. Let's check. If I use x equal to 3, I'd have 3 squared, which is 9, minus 3, which is 6, and then 6 minus 6, 0. So when x is 3, that will make this denominator 0. When x is negative 2, I will have negative 2 squared, which is 4, minus negative 2, which is plus 2. So I'd have 4 plus 2, 6, and 6 minus 6 is 0. So both of these x's make my denominator equal 0. That means that when I write the domain for this function, I can use all real numbers except x cannot be 3 and x cannot be negative 2. And there's your domain. So the trick here is make the denominator equal 0. Find out what x's make the denominator 0 by solving it. And then those x's you exclude from your domain. Here are some additional examples. We did these in class. This one is very simple. My denominator is x plus 5, so what I said is I will make my denominator equal 0 so that I can find what x makes this denominator 0, and therefore I can say any number and exclude that x that makes my denominator 0. For this one, same thing. We make the denominator equal 0. We solve. This is x plus 3. I can factor x minus 3. I find two x's and x equal to 3. Right? If I solve x plus 3 equal to 0, x will be negative 3. And over here I'll get x equal to 3. These two x's are the x's that will make this denominator 0. Therefore, I exclude them from my domain. The domain can be any real number except x equal to 3 or negative 3. So x cannot be either one of these two numbers. Otherwise, I will get an undefined value when I plug these two x's in there. Okay?